Hey everybody, welcome to our next day in math. So I'm going to try to keep these videos going just in case PowerSchool is having issues. I'm going to send you a document with links to all the videos. This should be posted public now to my YouTube channel on through the school email, so you should be able to find all of them from the same spot at this point. So what I want you to do now is go ahead and pause the video at this slide. Go ahead and try these in your notes just as a refresher of what you should know at this point when it comes to multiplying polynomials, okay? Okay, so going back to what we talked about previously, green doesn't show up, hold on, is that if we're going to distribute a monomial, we're just going to be multiplying. So this would be the equivalent expression or the distributed expression of 6x squared minus 21x. And the second one would end up being, let's see, 5x times x squared would be 5x cubed. And then 5x times 3x would be 15x squared. Remember, we're adding the exponents because we're multiplying. And then 5x times a negative 8 would be negative 40x. Okay, so just a little bit of a refresher. If you're watching this all on one sitting, that's probably not the way you should be doing this, right? You should be working on these individually day by day just to kind of stay on top of things. So that's what the first, 6.2 basically was about, other than the factoring portion. So distribution. So when we talk about today's topic, I'm actually going to back up to a different title because it'll make more. Actually, no, we're going to leave it on this one. So 6.3, multiplying polynomials using the FOIL method. That'll make sense when we get to it. All right, so the main question here, what you should be able to answer when we're done, is how can we apply the FOIL method when multiplying binomials? So previously, we were multiplying polynomials by a monomial, so multiple terms by one term. And now we're going to be seeing some where we have two binomials. Okay, this is probably the most common and what we're going to be using a lot of for the next several weeks. So make sure you have a firm understanding of this. There's also a little bit of shortcuts that we can work on that I'll tell you about when we get to it. So basically the FOIL method is just an acronym. It stands for first, outer, inner, and last. Now what that's referring to are the order that you do your multiplication or your distribution. So notice I've circled the first term in both binomials. So when you get to first, or the F in FOIL, it's going to be the first term times the first term. So x times x would give us x squared. O stands for the outer terms of the binomial. So let me switch colors here. We're talking about the outer term, the x and the 3, or positive 3. So we're going to multiply those next. That's the outer terms. So x times 3 would just give me a 3x. Change colors again. So the I stands for inner. So obviously it's the opposite of the outer. So the inner terms would be the 4 and the x. So 4 times x would just give me a 4x. And let's see, all these colors. We'll go back to black. Last stands for the last term of the first binomial and the last term of the second binomial. So we're going to distribute the x to the 3 the 4 to the 3 as well. So 4 times 3 would be 12. And you're going to see a recurring pattern for all the ones that we do here. You're going to have these two middle terms that end up being like terms. So we're going to combine those. So x squared plus 7x plus 12. That's supposed to be a 12. Okay, so when you're done, if you use the arrows to kind of keep track of everything, you should end up with distributing the first term to the first term to the last term, and then again on the bottom, the second term times the first term, and the second term times the last term. So FOIL, first, outer, inner, last. Okay. All right, so go ahead and pause the video here and try these three. It should be fairly quick. Try to do them in a column like I have them here. It'll make things a little easier to recognize the pattern when we get to that point. So write it across your paper and then solve them right underneath. Okay, hopefully you paused it long enough to do the problems. If you did it correctly, you should get x times x is x squared, x times 5 is 5x, 2 times x is 2x, and 2 times 5 is 10. Combine these like terms in the middle, and you get x squared plus 7x plus 10. Okay, second one in the middle, we're going to distribute the x to the x and the x to the 9. So x squared plus 9x, and 8 times x and 8 times 9. 8 times x is 8x, 8 times 9 is 72. Combine our like terms right here, so x squared plus 17x plus 72. For the third one, x times 3 is going to be x squared plus 3x, and 6 times x and 6 times 3 would give me 6x plus 18. Again, combine those two middle terms. Excuse me, it's going to be x squared plus 9x plus 18. Sorry for the dark on dark. I know it might be hard to see. So hopefully you can start to see a pattern coming out of this situation. So first thing you should notice, I mean, if I'm looking for some of the obvious things, is that these are all positives. They won't always be, but this is kind of the first step towards recognizing a pattern. Now, the pattern I'm referring to, hopefully you recognize that they're going to start following this pattern where it's x squared followed by a single x term followed by a constant. And that seems to happen more often than not, so something to think about. And there is more to the pattern. We'll get to it in a minute, but what I want you to do is now go ahead and take a look at these three. Now, if you're comparing these, you'll notice it's the same problem, right? With one small difference, okay? Now we have negatives as part of one of the binomials. So pause the video here, try these again. Again, do it across the paper, solve underneath. It'll help keep things orderly, and that way when we draw our conclusion at the end, hopefully you'll be able to see the pattern. All right, so let's check your work. X times 5, x squared plus 5x. Remember, this negative sign goes with the 2, so it's actually a negative 2 times x and a negative 2 times 5. Now when I combine the like terms, I have x squared plus 3x minus 10. Doesn't matter where the negative sign is. Notice it's in the second binomial this time. So when I multiply x times x, hey, guess what? I still get x squared. Hopefully you like x squareds because you're going to have a lot of them. X times negative 9. Don't forget the negative goes with it. It's negative 9x. And then 8 times x and 8 times negative 9. So positive 8x, negative 72. Combine like terms and I end up with x squared minus 1x minus 72. All right, and for the third one, nothing different. X times x, hey, x squared again. X times 3 is 3x. And then negative 6 times x and negative 6 times 3 is going to give me a negative 6x minus 18. Combine like terms, x squared minus 3x minus 18. So let's just stop for a second and take a look at what we've got here. If I compare this to the slide prior to this, okay, look at my answers. So let's take a look at the first one. So notice that the first term, or let's highlight it here. The first term in each one stays the exact same, right? It's still x squared every single time. Also, if you notice, what else is the same? Are the last term. So far, doing this makes some minor changes. They're not identical, right? If I look at the first slide, I've got positive 10, positive 72, positive 18. But here I have negative 10, negative 72, negative 18. And then obviously the middle terms are different, completely different, right? You got 7x, 17x, and 9x, but over here we've got 3x, negative 3x. So, do you spot the pattern yet? If not, that's okay, because we're going to take a look at another set of 3. And now instead of just having one negative sign, you can probably guess what's coming. Both negative signs. All right, so let's see if you can predict what the result's going to be. You can probably guess what the first term is going to be, hopefully at this point, right? Because you still have x times x. X squared, negative 5x, negative 2x. I forgot to say pause it. So, pause it and solve these and then come back to the video. Now we've got negative 2 times negative 5. So I'm back to a positive 10, which is what I had on the first one. Combine like terms, I get x squared minus 7x plus 10. For the middle one, I've got x squared again, minus 9x, minus 8x, positive 72. Combine like terms, I get x squared minus 17x plus 72. Third one, x squared minus 3x, negative 6x, positive 18. Combine like terms, you get x squared minus 9x plus 18. Okay, so let's compare what we've got now. All right, I'm going to go back to the very first slide. So take a look at what we've got here so far. We got negative 7x plus 10, negative 17x plus 72, and negative 9x plus 18. If I go back to the very first one, you should notice something at least mildly interesting. I think it's interesting. It's the same numbers, right? 7x, 10, 17x, 72, 9x, and 18. But it's different because that middle term is negative. Okay, so a small difference. Also notice that the constant values, the last term, right, 10, 72, and 18, those are all the same as well. Have you spotted the pattern yet? The pattern is important because it's going to help us when we go to factor these, okay, which we're going to do next time. But for right now, it's easier to spot the pattern and use the pattern when you're multiplying binomials. So what I want you to do is take a couple minutes, think about this this question here. Normally we would be discussing this in class, so we're going to do this in class as well. What did all the expressions have in common? Think about what was the coefficient of each of the trinomials created. Okay, what were the coefficients? And so what I'm talking about is think about the numbers in front once we're done, right? So here we have a 1, x, a negative 7x, positive 10. So those are the coefficients I'm referring to. And what was the relationship or the pattern of the b value to the c value? That's going to sound confusing until I write this up here. So what we're actually referring to is ax squared plus bx plus c. And actually, I can even simplify this further because the a is actually 1. So x squared plus bx plus c. This is probably the most common trinomial you're going to come across. Okay, it's going to be in this format. Remember, b and c are just placeholders for numbers. Okay, so if I go back to this slide here, if I'm looking at, say, this first one, the a value is 1, so I'm going to ignore that for a second. The b is negative 7, and the c value, the constant, is a positive 10. So think about that. Pause for a second. Come back to this. If you think you spotted the pattern, great. It's going to make life easier for you. So don't do that. So what's the pattern? Mr. Perez, just give it to me. So here's the pattern, guys. If I was to take a look, this might be a lot easier to see. If you didn't notice the pattern, let's just make up a problem like x plus 2 and x plus 6. Okay, so hopefully you spotted first the number one pattern being that the b term, that middle term is going to be positive, right? Because I have two positive numbers. You should also recognize that, okay, that means the c is also going to be positive because I'm going to be multiplying a 2 times a 6. So here's the shortcut for those of you that want the shortcut. If you want to just keep doing FOIL, that's fine. There's nothing wrong with it. We're going to keep using it because we're not always going to have an a value that's 1, and it's going to mess some things up. But for right now, you can safely say that this is always going to have an x squared first, right? X times x. You can also safely say that the last term, so let's just write this as x squared plus bx plus c. You can say that that last term is going to be the product of these two numbers, right? 2 and 6, because 2 times 6 is going to give me 12. So I know that my c value is going to be 12. And here's the cool part. The middle term is going to be their sum. Okay, so let's write this down. C is going to be the product of those two numbers. And if you recognize the pattern, the B is actually going to be the sum. Why is it going to be the sum? Because we always end up adding like terms. If you do enough of these, you're like, oh, it always ends up being those two numbers added together just with an x with them, right? Because really what I'm getting is a 2x plus a 6x. Really, I should have kept it the same as all the rest of them. Should have went up here. Whatever. Doesn't matter where the arrows are. So I have a 2x and a 6x. So when I add those together, the shortcut is just go ahead and add them and stick an x on them. Okay, it makes life a little simpler. So if you want to see another example real quick, let's say I had, well, x minus 4 times x plus 3. All right, so let's use that same methodology here. Let's go. We know the first term is going to be x squared. We know the second term, the middle term, is going to be this number, negative 4, plus that second number, positive 3. So add them together, negative 4, positive 3, you get negative 1x, or just negative x. We know the last term is going to be the product of those numbers, so multiply them. Negative 4 times positive 3, negative 12. So the shortcut does help, makes things go a little quicker. The faster you can recognize that pattern, the easier factoring is going to be. Factoring these trinomials is going to be when we get to that point. Okay. If you don't see the pattern, it's okay. It'll come to you. Just keep multiplying with FOIL, first, outer, inner, last, and eventually you'll start to see that pattern. Okay, you'll recognize that, all right, this is a negative 4x, and this is 3x, right? If we did it all the long way. So if I added 3x to negative 4x, I get negative 1x. All right, so that is the end of this one. We're going to go ahead and stop there and see you next time.